Hello, hi, Monica. Good afternoon and good morning to you
Good
all.
afternoon.
Thank you, LJ Group, to invite the Bahamas Maritime and for the opportunity to speak. Thank you very much. Um, we will be here. My name is Alessandro Lo Piccolo. I'm the Assistant Director of Bahamas Maritime. I'm here today to present and talk about the latest green tech on board cruise ships. As you might know, the Bahamas has a large passenger ship sectors, and we through them we learn quite a lot. We have a lot of experience that we gather in the house, and we're happy to share today what we learned today so far. Without further ado, the agenda for today, we're going to be talking very quickly about the authorities' roles and the challenges in promoting innovations that we have, and as well in keeping vessels in compliance, and also about talking about the sustainability technology that we have today, such as a thermal waste treatment device and fuel cells and waste heat recovery systems. Bear in mind, these systems can be also used as a retrofit installation as well as a new build. So the authority roles. So what we do is to ensure, first of all, that anything that is installed or assessed doesn't impair any other instruments. So in other words, what we want to do is to ensure that if we see the system that may be very good from an environmental perspective, it doesn't present a threat to the safety of the crew. So this is a main topic that we always look at, scrutinize the system in any angle. The second bullet point, talks about how we approve the system, what regulatory framework we use and apply, and to ensure that the system is also recognized internationally, so the ship doesn't have any problem in other ports. So the communication is well disseminated via certification of the systems, as well as by using other means such as the IMO database. The last one, bullet point, is also to ensure that the system that is presented, it's adequate for the crew. So meaning that in terms of qualifications and knowledge as well, it has to be working, as well as the number of the crew, because the number of crew is going to be still the same. So if you're going to install a system that requires additional money, that maybe is another issue that we have. So we try to keep that one in mind as well, whether training is required, what frequency this needs to be maintained, and to what standard. So what the challenge that we have, of course, quite often when a novel system comes in, it's always difficult to identify whether there is a framework already being established. Quite often systems are new as the technology progresses, and the IMO is not up to date with regulations, so which leaves the administration in a difficult position when we want to try to assess and work around. Now we're all moving towards the goal-based standard, which allows more flexibility in terms of reviewing systems. But as of today, we've been able to try to provide other different systems to try to work around. So when there are no regulatory framework or standards, also the historical data is a quite sensitive one, because sometimes we don't know what has happened on the system. So maybe the system has been used for years on shore, but we don't know in a marine environment how that particular equipment behaves and what environment it might be. Also, lack of experience for potential crew coming on board. So we're having lots of trainings, but what about experience? So we need to try to provide or establish some way or the other through the cooperation with ship owners to provide that one, so we can keep the crew up to scratch. And also recognition from the other local port authorities as well. So as anything we do, we want to make sure that it doesn't have impair any local regulations elsewhere. So talking about sustainability, green, we always talk about. So carbon reduction. This has been a huge topic and will be with us for many, many years to come as well. But very quickly, there are ways and ways to reduce the carbon reduction. So one, it will be always be the primary generation. So you can change the fuel, and that might be just already massive change of carbon reductions, or by achieving efficiency systems on your ship. So obviously, primary generation is also easier when you have a new build, but for existing ships, that's not always an option. And therefore, we're going to be talking a bit more about how you can achieve efficiency of all the system that you might or might not know or heard before that might be help to improve the efficiency of your ships. Talking about data, raw data, is a generic one terms. Combustion engine has about between 10 to 40% efficiency. A combined gas turbine plus heat recovery normally is achieving about 60%. But to give you an example, a fuel cell is indications gives about 75% efficiency. So this is just how quickly you already increased quite a lot of your operation through installing a fuel cell, for instance. So without further ado, we're going to quickly talk about this is a system that we encountered in the last year or so, and we've been verifying working on these projects. So the first one is the waste heat recovery system. So this unit is very simple. Use the Rankine cycle systems to generate electric power. So by means they use hot cooling water from the ship's main engine to generate power. So is another additional element that you add as a part of your energy to produce power. And so these pictures represent what it looks like on a ship installation. As you can see, is generally in machinery space. It can be on banks. It can be many other ways. The system is very simple. However, there is a compliance issue here. Which one it is? So the system works with the acetone, and as we know, acetone is toxic, and therefore there are other works that needs to be done. So the flammability is quite high, the low flash point in the machinery space, below 60-degree temperature, ventilation issue, what training, what fire suppression system we have, fire protection system, pollution risk. So we want to make sure that if we're going to going ahead and installing this system, it's not going to create a threat to the crew, as well as a fire risk, additional fire risk that we don't want. So what we do is there are ways we can always try to overcome these issues, and this is obviously through thorough analysis. We risk preparations, we can try to identify all the risks that there are, and minimize the risk to the optimal maximum. So talking about systems, just to give you a bit of an expanded view, what this exercise requires between hazard identification of the system, risk-based analysis, FME, hazard operation, and the list goes on. Once this system is finally fitted on board, installed, certified, and qualified, does that mean we can now roll and fit to other ships? And the answer simply is no. The reason being is because each ship has a different layout, different risk, different system on board, and perhaps something that might work really well on passenger ships or Ro-Ro packs, maybe not working so well on an offshore unit, for instance. So going ahead on the agenda, we also have these MAGS thermal waste systems. Now, the initial overview that you might have is that it indicates to be an incinerator. At current stage, on our ships, they are certified as an incinerator. However, this system offers a lot more than just incinerating. So first of all, the system is capable basically to use, thanks to this technology, to convert all combustible materials such as plastic, paper, textile into energy. And also the way it works, the heat generated from the combustion chamber is recirculating to a gasifier chambers to create a self-sustaining process. Now, the unit, the OEM in particular, claims to have a huge fuel saving. And that's how we start talking about efficiency, carbon footprint, and also so forth. So they claim that they used about between 0 and 20 liters a day of MGO, and can dispose up to 1 ton a day. Why we're also talking about this one? Because the way the system is designed has an exceptional clean emissions. Obviously, it's got a system through scrubber systems and everything else, but the clean emissions are exceptionally low, and that allows potential rooms to have the system operating in port. Now, as it today is not, again, the IMO structure is not there yet. There is work that is undertaken at the moment at the PPR7 paper in 12. This paper, essentially what it does is basically identifying 2 different levels, level 1 and level 2. Level 1 is basically similar to the incinerator system, but with a continuous monitoring, which at the moment the normal incinerator do not have the system. And level 2 is similar to the EU regulations for the landfill thermal waste system. Looking at the specs presented to us, the actual system is well below the requirements, which is already quite restringent from the level 2. So that basically, essentially, what it does say is that the system operates at better and optimal level than the actual system that potentially are fitted on shore on the landfill. So as a Bahamas, we are working closely with the owners and operators to establish a framework in order to certify these units as a gas fires. But the important things to talk about is we've been talking about all this good energy saving, carbon footprint, but there's also a little more to expand. Is what might happen at the landfill. So when we talk about the waste storage, the waste storage on board ships, and we're talking about these large passenger ships. Now we have about 8,000 people on board. They're quite large, and there is a lot of waste to dispose. When the waste storage is on board, is already presenting a risk itself when it's on there. When landing the system offshore, obviously there will be truck involved, transport, incineration on shore, not to mention that the risk of fire on those landfills, which might be impacting more on the environmental. I don't know, hurricane rains that may fly the plastic back to the ocean again. Obviously, for cruise ships, is becoming an issue. The time that they have to spend to offload the garbage and then the handling of itself. So they're obviously choose a destination port which they can handle better. For a port itself, if they have not such a difficulty, they can have a small reception facility, so that could work. But when we're talking not just about large passenger ships, let's think about those expedition vessels. Again, those expedition vessels would be somewhere remote and they have a restricted capability, so they need to retain on board as much as they can. So moving forward in the agenda, and again, I'm trying to rush up because we only have 20 minutes, and I want to try to make sure that we nail all the principles we're trying to talk today. Obviously, is largely discussed fuel cells. So when the advantage of the fuel cell, so the use of a fuel cell does not only result in reduced air emissions and improved fuel efficiency, but also increase the availability options to ships owner for complying with the increasingly stringent environmental regulations. So what can fuel cell be considered a novel technology? Actually, no, but it is to some extent novel on the ship application because in the ships is becoming a new thing. But there's been a large use back in the days for this technology. What's the risk and what are the new challenge again? We're going to be talking again. Again, this is just to show from an administration the challenge that we have. The IMO papers are still in current draft, so the triple C7 is a good paper to start, but it's in draft status, so that means it can change. So it will be presented to the next MSCC 105 session, which will be in April 2022. And if it gets rejected, it needs to go back to the working group and be drafted again. It shouldn't be the case, and I don't foresee it will change too much if that becomes the case. However, it is an option on the table. So this presents a challenge not just for us, also for ship owners when they choose a system they have on board, and we have to draft regulations for those ones, whether it's the fire protection systems or extinguishing systems and so forth. Because if that can change, we need to then go back and retrofit and change everything again. So the question remains, so with regards of the alternative design arrangement, the systems, just to bear in mind, they are subject to alternative design arrangement. It is stated on the AGF code in SOLAS, and the applicable circular guidelines for this one will be the circular 1455 is the one that will be used again, which is scrutinized and goes into great level of detail for to ensure that from any angle, operational and the system installations are addressed properly. But the question also is if there are any other supporting guidelines or standard out there. As a matter of fact, because this is not a new system, we have a large amount of ISO standards being issued for each module and type, as well as from IAX members as well as EMSA. They all developed their own sort of guidelines and rules. Going forward, again, what's the scope of the risk analysis that we have on fuel cells? And this is basically to identify all possible failures that have been correctly addressed, evaluate the consequences for each failure of the systems, identify that the failure detection methods is in place, and identify, most importantly, that the corrective measures are in place at all times. So if something fails, what happened next, and so forth. So they spend lots of times in doing this exercise. So going back again for the fuel cell, to complete what we've seen today on our passenger ships, we've seen that in the passenger ship sector, there are two trends at the moment that are being used as a technology of fuel cells. So one is called the proton exchange membrane, also known as a PEM, and the other one is a solid oxide fuel cells, SOFC. The two type of trend as well of fuels are on LNG and methanol at the moment. There is an appetite in the room for hydrogen and ammonia, but at the moment this is not been developed, or at least not on our table desk to address at the moment. But it will be for sure something that we might see in the future to come. With regards again with fuel cells and LNG and methanol, again there are new combustibles experience. We go back again on the same principle, bunkering process. So where is it stored, where is it stored, and so forth. The list goes on. But strangely enough, sometimes you see LNG ships, which they might gonna choose as methanol just for the fuel cells, which you would imagine maybe to use the LNG again because they already have an LNG on board. But again, it's another level of redundancy that they might want to create. So what's next is a nice question for the future, right? And I think probably we all know this, and we're probably prepared to see this coming. That's what we probably going to see quite soon. But funny enough, there are looking at this one, which it looks quite futuristic, almost going back in the days. I'll say it's there's been the regulation being drafted back in 2013, believe it or not. So the MAPC 1 circular 815 addressed the guidelines for innovative energy efficiency systems, and address the wind propulsions and the generation of electricity through waste heat recovery system. So they go their own category, and this is basically to allow to work more on the ethane EEDI, which is largely discussed. Again, I hope you find this presentation interesting. Thank you very much to you all for listening. I'm happy to take any question you might have.
Alessandro, thank you so much for the presentation and started our small session focusing on ports and maritime authorities. So let's jump to questions. With regards of the waste heat recovery system, noting that acetone has been used in machinery space, what extinguished media has been used and what power can it generate?
Thank you very much, Monica. So for this particular study that we done, obviously it was a bit of a challenge in not being able to use CO2 in a low space because again, you might have a crew going in and out. So for that one, the media that's been used is the Novec 1230, which is a fire suppression system that allows us to release the extinguisher media without poisoning the crew at risk. So they can't suffocate because of that. So it works really well in many applications. We also see a trend of more ship replacing CO2 and using this system just because the risk is less. As you probably also seen on the photos, the photograph that I presented before, the system stays within an enclosure and is sealed within enclosure. So even if there's an spill of acetone, stays there. There are sensors to detect, and if there is a flame, immediately the system will be released. And also there are to avoid any possible level of concentration for explosions, there is a ventilation forced at about 30 air changes per hours we have, and that will reduce. With regards of power generation, do we have about the proposed system? I think that what they're presenting is between 150 kilowatts to 1 megawatts. The one that we have on our fleets, they choose to install 6 units of 150 kilowatts each, which doesn't sound like quite a lot, but it still helps out of just waste of heat, basically. They're producing nearly 1 megawatt combined.
Great, thank you. And what about the max thermal waste? As there are no current rules, how can these units operate in ports?
That's correct. It's a challenge. What we basically doing is, because there is a draft document, we think it's mature enough. We looking to cooperate with the owner to potentially moving forward and accept this certification under the draft regulation. However, because we can't mandate anything to other ports, what we advise is the owner to seek local consent from each area where they're trading. So for cruise ship sector, that would be a lot easier because they normally engage in a fixed voyage. So by doing so, they can get agreement, local agreement to operate the system in port by providing the advantage they might have, and that will allow them to use it. Maybe they're not going to be able to use at all time, but probably for the vast majority of the time, they will be able to use it once they get the agreement in place, although the regulation is not yet finalized.
I see. And then what about fuel cells? What fuel cells configurations are currently installed on Bahamas vessels and what power they generate?
So the one we've seen so far they are the solid oxide fuel cell. They're running on methanol. I'm aware that there is some other company. I think is AIDA as the other type, the PEM one, and they're running on LNG. In terms of power, the indication that we have at the moment, again, this is all study at the moment. Don't have the system on board as yet. It's under construction. So we seems to be having about 0.5 megawatts. And the owner is looking to install 8 units, which that will probably generate about 4 megawatts. So generally speaking, large passenger ships, they use about 8 megawatts in terms of just for the hotel. So it's a constant load that they're always going to have. So this one would take pretty much, if there was a big size of ship, that would take about half of the load will be already taken by the fuel cells automatically.
Okay, and there's the final question from the previous speaker, Nikos Xidas. Would you consider also LPG as fuel for the fuel cell?
There could be an options there. Again, normally it's not a choice from us. It's the owner normally choosing that for on their ships. But we're happy to assist, any novel technology that might come.
Excellent, Alessandro. Thank you so much for taking the time to present today, for giving an overview of what's happening at the Bahamas Maritime Authority. And we appreciate your time and thank you for the effort.
Thank you to you all. Thank you very much, Monica. Bye.
Thank you.